Hello everybody, welcome back to Fastware. So today I'm going to show you how to implement a bounding box and visualize it like this. It's only 5 little steps, the amount of code is negligible, and I'm sure we're going to have a great time. So to start, what you need to do is implement a computation of a bounding box. Fairly simple, you have a bunch of vertices, we'll loop through them, we pick up the minimum and the maximum for all the components for X, Y, Z, and that's it, right? So minimum and maximum. We want to find the size by computing max minus min, the center by adding these and dividing by 2, and then we create a matrix. Step 2 is taking that and creating a vertex array object. So for that we have the vertices. So the square, the cube, is a unit size, basically from -half to 1/2, it's 1, right? We understand that. And then you have indexes. So please note that these indexes start from 0, 1, 2, 3, then 4, 5, 6, 7, and then 0 to 4, 1 to 5, 2 to 6, 3 to 7. So what that does is you have the loop on the top of 4 of them, the loop on the bottom, just 4 of them, and then the other 2 are just line segments connecting the top and the bottom. That's pretty much it. Fairly straightforward. So what we want to do here is, because we render instanced, meaning that we want to do exactly the same thing many times on the screen, we create our vertex array information, which is fairly straightforward. We have 3 buffers. The data that will be changing for each of the objects are going to be there per vertex. Their float information, which is basically this information, and then per instance we want the matrices, the models where the particular thing appears on a scene. We create this and we have an update buffer because I wanted to make this visualization to rotate. Obviously you probably don't want to do that when you're actually intersecting with these, but as a visualization tool I think it looks cool, so I did that. To use it, it's fairly straightforward. I have a couple of shaders, which we'll look in a second. We create the program out of these shaders. We compute the bounding box for our vertex positions, right? Because we have that sphere, we want to compute the bounding box for it. We initiate our model, so how many instances we're gonna have. I think we have like 40,000 of them. And then we allocate all the memory necessary to basically store this. We want to create our vertex array object and get that bounding buffer, and we create 3 entities. So currently my system doesn't allow entity with multiple render passes, but I guess we will handle that sometime in the future. For now I just create 3 entities as a kind of a simple workaround with exactly the same program IDs and whatnot. So as you can see from those indexes, from 0 to 4, we have a line loop, right, which renders the top. From 4 to 4, so the bottom one, another line loop, and then with offset 8, another 8 indexes, which are going to be lines, which take only 2 indexes and then draws the lines. And then all of these with the instance count. And that's pretty much it what we have here. The only other part, which now is, I guess, this is part 3, so next thing is part 4, is how to set it up for rendering. So I have a little control block, show bounding box. So we set for that program ID the projection view matrix. We update the buffer with the latest computed data, which we do just above here, compute bounding box, model matrix these and whatnot. And then we render those 3 targets, which I showed you how to do earlier. The bounding box vertex shader basically looks very simple. So these are per vertex information, which we set up, these half to half vertices. The model information is actually the instanced information, which coming through there. you saw how we set up at location 7 right here, our projection view matrix. And then we're basically just multiplying them together to get the GL position. That's very straightforward. And a fragment is even dumber than that, which is just a static color, which we're outputting that lovely green that you saw. So to recap, compute a bounding box, set up a vertex array buffers, and if you need an instance one, so a buffer for that too. You compute everything, set it up, your programs, right? Which we've done here. In your render target, so you have loop on the top, loop on the bottom, and 4 straight lines. You update your data, and then you basically just set up the projection view matrix and update your buffers and render those 3 targets. That's about it. And this is, again, how it looks. So we have a lot of objects that we can see, rendered, bounded. So as you can see, the bounding boxes rotate. In the actual octree implementations, that's probably not what's gonna happen, because it's gonna be the AABB representation, which is the axis aligned bounding boxes. But as a representation, I think it looks pretty cool. Let me know what you think in the comments. I think it's pretty cool. So if you want to keep track of this project, I would invite you to visit a link in the description where I set up this sort of a project management thing. Everything that I'm looking to do, everything that I'm doing, like visual debugging system, bounding box visualization, collision system, a bounding box. Next thing, we're going to be implementing the box ray collisions. So we want to fire a ray, figure out if in the octree that collision actually works. So that's what we're going to be trying to implement next time. And for now, I'd like to say thank you. Have fun writing fast code. Cheers. Bye.